Who has the best cordless table saw? Is it DEWALT, the FlexVolt, which has been out for about 2 years? I've been using it ever since it came out, and it is awesome. Or is it the brand new Milwaukee 18 volt? While both these saws look pretty similar, they are certainly powered with different voltages. The DEWALT FlexVolt uses a 60 volt max, which is a 54 volt battery pack and motor, and Milwaukee uses an 18 volt pack and motor. So while they use different voltages, they were both tested using the same total battery pack energy of 216 watt hours. We used the same testing format in this head-to-head as we did on our cordless head-to-head we did a few months ago. And we broke things down into several categories. So the categories that we felt were the most important to you was precision and accuracy, performance, which is power, price, and ergonomics. Those are your decision-making factors. Let's talk about precision accuracy. In this category, we evaluated the accuracy of the saws straight out of the box. How easy was it to set them up and then make calibration adjustments? We also discussed the quality of the fence system and how it relates to ripping accurate cuts. In the performance section, this evaluation took a deep dive into the power of the saw's motors and how well they ripped 3 different materials. We tried to include things that would cover a wide breadth. We looked at plywood, pressure-treated southern yellow pine, and Ipe, 3/4 inch Ipe. And then lastly, we looked at price because it's always an important factor in determining which saw is best for you. We've included the current pricing online for each of these 2 saws at the time that we're making this video. And lastly, we looked at ergonomics because, guys, whether you like it or not, ergonomics is really important to the user. It's an important category to consider when purchasing a power tool. And we also included functionality with this category, the ergonomics category. So look, function, features, specifications. We cover the features and specs of these saws in the article on toolboxbuzz.com. Remember, the website article always has way more detail and specs. But suffice to say that these 2 saws are nearly identical with specs, with only a noticeable difference being speed of the blade and the voltage. Size, weight, depth of cut, features, all very similar, and you'd swear they were a red and yellow version of the same saw. So when it came to precision and accuracy, the winner of that was the DEWALT saw. We measured the manufactured tolerances and ranked the saws for their as-built accuracy. And to assess that, we looked at 6 areas, and we wanted to measure and compare those areas. Table flatness, accuracy of 45 and 90 degree stops, blade parallel to the miter slot, and fence parallel to the miter slot, and then obviously blade runout. We evaluated the flatness of the table by measuring the edge of a precision ground flat bar that we use, measuring bar, across the table. We placed feeler gauges in any gaps we saw. We measured those differences. We used a light to help us as well. We took 4 different measurement directions across the tables. The flatness measurements were close and are detailed in the website article. So if you need to see the numbers, go to the website. DEWALT edged out Milwaukee by taking 2 out of the 4 measurements and 1 tie. We measured the accuracy of the factory set 45 degree stop using a Wixie digital inclinometer. Say that 3 times fast. Basically attach it to the blade, and we used a mechanism, the saw mechanism, to adjust the blade to incline to the point at which the blade or trunnion hit the factory set 45 stop. We did every test we performed twice to ensure that we could get readability, or repeatability, I should say, of each measurement. And in every case, the result came out to within 0.1 degree of the prior test. DEWALT was 45 degrees, spot on. Milwaukee was 46.3 degrees. When we looked at the 90 degree stop, DEWALT was 90 degrees and Milwaukee was 89 degrees. So DEWALT won that one as well. Blade parallel to the miter slot. We used an eye-gauging digital dial indicator, and we used that to measure the accuracy of the blade position to the table miter slot. We used the same new, never used saw blade for both saws, so we switched them out. If the blade and the miter slot were closer together at the rear of the saw, the dial indicator would have a negative reading. if the blade and miter slot were further apart at the front, it was a positive reading. So DEWALT was 1/100th of an inch, and Milwaukee was 8/100th of an inch. So again, DEWALT took this third category. We looked at saw fence parallel to the miter slot. So since we tested the amount of difference in parallelism between the saw blade and the miter slot in the previous test, we really only needed to see if the miter slot is parallel to the fence. To see if we do that to see if there has a parallel relationship between the blade and the rip fence. Make sense? So we used the same eye gauging digital dial indicator, and we measured the accuracy of the as-built factory fence to the table miter slot. If the fence and miter slot were closer together at the rear of the saw, the dial indicator was negative. It gave a negative reading. So look, a negative reading means that materials being cut might be subject to being a pinch, might create a pinch point, and that's a kickback or a possible likely to occur kickback situation. If the blade and the miter slot were further apart at the front of the saw, we've got a positive reading. So we use that as a measurement. DEWALT was 32 thousandths of an inch, Milwaukee 65 thousandths of an inch. And again, DEWALT took that category, but a really tight, close tolerance. So once we had that, we adjusted both fences, and the adjustments were easy to do, guys. Simple, simple. Blade runout. Blade runout is basically a term that describes whether or how much outside edge of the saw blade wobbles, and that's while being held by the motor shaft, right? The arbor that holds the blade. In this comparison, we use the same never been used blade to measure both saws, and using the same blade results in an accurate measurement in the saw contribution, basically to runout. We didn't have a plate to measure because these are smaller saws. So we use the same eye gauging dial indicator to get the results, and we were really careful to rotate the blade using the outside rim of the blade so that we didn't cause any side-to-side movement in the saw blade to introduce errors into our measurements. We recorded the maximum reading on the dial indicator, resulting in running this test twice. Every test was run twice. Milwaukee, 49 thousandths of an inch. DEWALT, 65 thousandths of an inch. So Milwaukee finished first in this one. Overall precision and accuracy results. We looked at that. We performed a total of 9 measurements in this category. DEWALT took 6 of them. Milwaukee took 2, and there was 1 tie. So DEWALT was the clear winner in this category. Then we looked at saw performance, and basically the winner of that was a tie. So under saw performance, the $1 million question is, about any cordless table saw, is how long will it run? So we developed 3 different runtime tests to put these 2 saws through, and we wanted to see how long you can run on a fully charged battery pack. Let me see. Yeah, these tests basically allow us to see how well they run during very different power demand cutting applications. So what do I mean by that? So look, we looked at 3 different tests. They included ripping 3/4 inch plywood, light demand on the saw motor, but similar to ripping pine, poplar. We rip plywood all the time. The second test was ripping 2x6 SPF framing lumber, kind of a moderate demand. We do it occasionally. Third test, 3/4 inch thick ipe or ipe, or however you pronounce it, high demand. So really high, I call it ironwood. We wanted to see the different demand applications would show different results for 2 dramatically different voltage saws. So 3 different tests, 3 fresh batteries. For this testing, we used 2 different blades. We used the DEWALT and Milwaukee blades. So for each type of wood, we installed a new blade. So for the plywood test, we used the DEWALT FlexVolt blade. That's the 24 tooth blade that comes with the saw. We did it on both saws. For the framing lumber, we used the DEWALT FlexVolt, again, 24 tooth blade. For the ipe, we used a Milwaukee 40 tooth finish blade because ipe is a decking. We're doing finish work. We're going to use a nicer blade, nicer cut. The Milwaukee used an 18 volt 12 amp hour battery pack, and that equates to 18 volts times 12 amp hours equals 216 watt hours. The DEWALT used their 60 volt pack, sorry, which is a 4 amp hour pack. So 54 volts times 4 amp hours equals 216 watt hours. Guys, the runtime results were close. For the plywood test, the DEWALT cut approximately 48 lineal feet more than the Milwaukee. We're talking 608 lineal feet compared to Milwaukee at 560 lineal feet. Framing lumber, DEWALT cut approximately 40 lineal feet more than the Milwaukee, and that's 264 lineal feet compared to 224 lineal feet. And lastly, for the epay decking, both saws cut 256 lineal feet. It's hard to believe, but they did. So the question is really, do either of these saws outperform one another when it comes to runtime? Well, yeah, clearly the DEWALT was better than the Milwaukee, but honestly, the difference is small, and that's virtually a tie. What's more impressive is the amount of cuts that these cordless saws can do on a single charge. Each of these saws were able to make, think about this for a second, over 70 rip cuts in 3/4 plywood, 8 feet long, 30 rips in 2x framing, 8 feet long, and 32 rips in 3/4 thick epay decking, ironwood, 8 feet long. So while these numbers certainly are not a big deal if you're ripping all day long, I don't do that, but some guys might on a table saw, but they are certainly impressive for punchless, trim jobs, all kinds of carpentry jobs that we do. Also, when you pair a second battery to either one of these saws, you're likely to be able to work all day long. All right, talk about performance. While cutting all the material for the runtime testing, we were able to get a really, really good feel on these two saws and how they compared to each other. Subjective, I get it. Both saws felt really strong and didn't have trouble cutting the material at all. Most notably, though, the Milwaukee just sliced through the material. It was a smoother cut and it felt stronger. The DEWALT, I would describe the DEWALT as chattering. It almost like was chewing into the wood. I don't know, Milwaukee cut more smoothly. It didn't bog down. It was a smoother cut. Overall performance, the runtime testing wasn't much of a surprise to us. We figured that the two saws using the same total battery pack energy should provide similar runtime results, and we were right, it did. While the DEWALT did slightly beat the Milwaukee in 2 of the tests, the difference is negligible. It really doesn't change the overall production between the two saws. Let me see. On the other hand, basically I felt that Milwaukee felt like it ran and cut smoother when compared to the DEWALT. And at the end of the day, we feel that the performance of these two saws really was too close to declare a winner. So we gave it a tie. When we looked at ergonomics and features, the winner was Milwaukee. We compared and evaluated several ergonomic and feature categories that we felt were important to users. Weight was one of them. Both saws weigh just over 45, both saws weigh over 40 pounds with the battery, without the battery. Milwaukee is 43 pounds, DEWALT was 45 pounds. Blade height adjustment. The DEWALT takes 36 turns of the wheel to get the blade to full height. 36. The Milwaukee designed theirs with 14 turns, way faster. Switch design. The Milwaukee has a better switch design. One of the pet peeves or the big gripes that a lot of guys have with the DEWALT is how that safety switch can easily turn off the saw when you let go of it. So you turn it on, you let go of that red little flipper, and that thing flips down as you remove your fingers, and the weight of that flipper hits the off button and turns it off. The Milwaukee doesn't have that design, and therefore is a much better design in our eyes. Blade changing. Milwaukee uses an arbor lock, so users need one wrench to change the blade. They also have 2 miter slots and can accept a dado blade for the Milwaukee, which is great. The DEWALT, on the other hand, requires 2 wrenches, which can be cumbersome and not as easy as an arbor lock design. Fence. Both saws have a rack and pinion fence. We prefer that design. DEWALT's felt a little bit more sturdy, but both were great. Adjustments and riving knife. Milwaukee has a tool-free riving knife design. You basically release a lever on the back table and the riving knife and the guard just pull right out. The DEWALT requires the user to take off the throat plate, remove the riving knife knob, and then remove the riving knife or guard. It's a pain in the ass. Pretty much big difference in my opinion. Hate that. Stand leg adjustment. The Milwaukee stand offers a one leg leveler to keep the stand from wobbling, but it broke on us once we got it out to a real job site after testing. So Milwaukee tells us that they're working on redesigning this and improving this design to correct this lack of performance in the stand. The DEWALT doesn't provide any feature like that, leveling. It's just a stand. Let's talk about the stand. The stand, they're both similar with one notable exception. Milwaukee included a simple clamp on the front that locks the table down onto the stand. So when you pick the saw up, you can move the saw and the stand easily as one unit. While the DEWALT doesn't have that, which means you have to move them separately, you kind of hold them both, the drag, pain in the ass. One key. So one big feature that Milwaukee offers that DEWALT doesn't is the one key technology on their table saw. So what is one key? One key is it gives you tool lockout, tool tracking, robust asset management features. Overall, guys, Milwaukee clearly spent some time looking at the features and ergonomics of this new saw. Clearly. All right, look, pricing. Obviously, pricing is a concern to many users, so this category is always important. We priced the saw, one battery, and a stand. Now, Milwaukee, the saw, scissor stand, 12 amp hour battery pack with a rapid charger is $549. The DEWALT with the scissor stand, 12 amp hour battery, and a charger is $655. I gotta let you guys know though, DEWALT doesn't sell kits, so we had to price those differently, and that's I think why the price difference. Whereas the Milwaukee sells it as a kit, which is smart, and I think that's really smart, especially with that 12 amp hour battery. Right now, the Milwaukee is $100 cheaper, and it uses an 18 volt battery for users already on that 18 volt battery platform. Milwaukee users are gonna be psyched. So, best cordless table saw. Which one's the best? Both table saws are great, and the tests were close. The DEWALT offers a slight advantage, or an edge I should say, on the runtime, but Milwaukee has better features and a lower price point. So, also, and Milwaukee uses the saw as a continuation or expansion of their M18 platform, unlike the DEWALT, which is a platform that you have to move up or move into, which is the FlexVolt line. So if you own either one of these battery platforms right now, this selection is easy for you. Just go with your platform. These two saws look like they could be twins. They really do. On the other hand, the paint schemes, their performance, other than their paint schemes and their performance, basically, it was a really close test. At the end of the day, the two saws are once again expanding the ever-growing cordless job site and cutting the cord. Guys, if you'd like more information on these saws, especially the specs and how we tested this, go to the article at toolboxbuzz.com. Please consider subscribing. Click that subscribe button, and we'll see you all at the next tool review. Take care.